Yeah, I put together a process map that can guide curriculum creation for projects within the big data curriculum, as well as the maybe a program flow also. So let me run you through it. I'm calling this big data mindset. So the process starts by present students are presented with a question. So for instance, can we tell if and when someone will get sick? So can we use data to tell if and when someone will get sick? Well, to do that, the question is what data is needed? So students are going to need to ask, what data do we need to know that? So they're going to do some brainstorming and some research, both market research, industry research, and social science research. They are trying to find out where can I get the data? So that's going to again be associated with research. Does the data already exist? If the data already exists, versus if it doesn't exist. So if the data already exists, having the students ask quality questions. Is the data relevant? Is the data accurate? So they got their hands on a bunch of data, but is it relevant and how much of it is accurate? I mean, those are strong questions. And if the data doesn't exist, how can I collect the data? So now we get into creating sensors or using and finding existing sensors and creating surveys and administering surveys. And again, these are engineers, these are writers and social scientists. So now let's say we have the data, whether it already existed or not, or we collected it ourselves. So let's say we have it. Now that I have the data, how can I transform it to analyze it? You can imagine huge, desperate spreadsheets and text files and all the different formats that data comes in. We got the data, but how can we transform it so that we can analyze it? Well, that involves combining data, organizing it, cleaning it. In industry, they call that ETL, extract, transform, and load process. This involves computers. Anything from a data technician, a data analyst, to a computer scientist who is reading tweets to, pull information out of tweets. So now that the data is ready for analysis, how can I make it visual to see trends and correlations? And so this is data visualization, it's reporting, it's taking a management mindset to figure out of all this data we have, what's relevant and how can we make that really visual. Now that you visualized it and now that I see trends and correlations in the data, are these trends legitimate? In other words, that's statistics. That's saying, is the sample size big enough? Is are there other kind of issues with the data that make the trends we see questionable? And that's a really important piece of analyzing data is, asking right up front the veracity of the data. And again, that's statistics, but it's also managerial mindset and just understanding the quality of data. But let's say that we do determine that the data is legitimate. Now that and therefore the trends we're looking at are legitimate. Now that I know the trends are legitimate, are they meaningful? And that comes down to a management mindset. You can have legitimate data, but that legitimate data and it can be showing you trends, but those trends may not be actionable, or if they are actionable, they're not worth it for some reason. And there are examples of that uh, that students could bump up against and be confronted with, that they have legitimate data, they have data that shows trends, but really there's no kind of nothing you can do with that. But again, that's management mindset. So that's teaching kids how to think like a manager. But let's say that the trends are meaningful. Now that I know the trends are meaningful, what can we do to take advantage of these? And again, put marketing managers, operations managers, they're going to take that meaningful data and they're going to do things with it and try to improve business, improve society, whatever they're up to. And then do these, so let's say they run marketing campaigns or focus on fixing some aspect of an engine based on the trends and data. Do these trends predict the future? So this is getting into more like again, statistics and really trying to understand the uh, predictive power of the data that you're analyzing. And then now that we found meaningful data, how can this data process be automated? So this is a big deal. It took all this work before here to get to the point of um, finding trends in data, but there are people out there who automate that process. So you click a button and the dashboard repopulates with all the data you need. And so that's data architecture, that's computer science. Now we're getting into artificial intelligence and machine learning, and really, and then really trying to automate that whole data process that we just covered. Starting with a question, can we predict when and if someone is going to get sick? Collecting the data, seeing if it already exists. If it doesn't, how are we going to collect it? Transforming that data into a usable uh, data set, visualizing the data and looking for trends, uh, judging whether those trends are legitimate or whether they're based on faulty data or the amount of data or whatever it is, and then making decisions on data, and then automating this whole process. So this is the big data mindset. This is a possible framework for how we can engage students, how we can structure a possible program, and uh, and so yeah, I'm looking forward to hearing your feedback on this.